Have you ever been stuck in a spot where your best move is completely tangled up with what someone else is about to do? That is the heart and soul of strategic thinking. Today, we're going to break down one of the most powerful tools in game theory for making the right call, and it all boils down to one simple question.
So, how do you do it? How do you figure out the winning move when you're up against another smart person who's trying to do the exact same thing you are? It sounds super complicated, I know, but there's a really clean, logical way to cut right through the noise.
See, the trick is to stop trying to read their mind and instead just find the move that's best for you, no matter what they do. This magic move is called a dominant strategy, and finding it means we have to look at each player's options totally on their own. Okay, so here's the textbook definition: a strategy that consistently gives you the highest payoff, regardless of what other people do. Now, I gotta stop right here because that phrase, highest payoff, is where pretty much everyone gets this wrong. It does not mean you just scan the board and find the biggest number you can possibly get. The real meaning is way more subtle, and getting it right is the key to this whole thing. This slide nails the difference. The common mistake is just looking for that one jackpot number, but that's not how it works. The right way is to break it down with two simple questions. First, if my opponent does action A, what's my best move? And second, if my opponent does action B, what's my best move? If your best move is the exact same in both cases, well, then you found it. That's your dominant strategy. Let's see how it works in practice.
So let's play a game. We'll call it the neighbor game. You and your neighbor have a choice. You can either forbear, which is like cooperating, or you can steal. The numbers you see are the payoffs. The first number is always your score, the second number is your neighbor's. So for example, if you steal and they forbear, you get a sweet payoff of 12, but they get a not-so-sweet -2.
Okay, so how do we find your dominant strategy here? We're going to step into your shoes and figure out your best play for each of your neighbor's possible moves, one by one. It's a really straightforward two-step process. All right, scenario one. Let's just assume for a second that your neighbor is a good person and chooses to forbear. So right now, we are only looking at that first column. Your choice is simple. You can forbear and get 7 points, or you can steal and get 12 points. Yeah, this one's a no-brainer, right? 12 is clearly better than 7. So in this specific case, your best move is to steal. Let's just lock that away in our memory. If they forbear, we steal. Okay, now for scenario two. But what if your neighbor decides to steal? Now we completely ignore that first column and only focus on the second one. Your choice is between forbearing and taking a loss of -2, or stealing and getting a +2. And again, the logical choice is crystal clear. Getting 2 points is way, way better than losing 2 points. So even if they decide to steal from you, your best move is still to steal. Are you starting to see a pattern here? So let's just lay it all out. In the first case, when they forbear, our best move is to steal. In the second case, when they steal, our best move is also to steal. Since the best strategy for us is steal no matter what they pick, the conclusion is pretty obvious. And that right there is what a dominant strategy is. Steal is the move that always consistently gives you a better outcome than your other option, regardless of what the other person does. Now, to really make sure this clicks, let's look at a quick counterexample, the classic chicken game. Here, you can either swerve or drive straight. Let's see if we can find a dominant strategy for you in this one. Let's run our two-question test. If your opponent swerves, your best move is to go straight, because you get 1 instead of 0. But if they go straight, your best move is definitely to swerve, to avoid a terrible crash and a -5 payoff. See that? Your best response flips depending on what they do. Since the answer isn't the same for both scenarios, there is no dominant strategy here. Makes sense, right? Okay, let's jump back to our neighbor game. Now, if you look closely at the numbers, you'll see the game is perfectly symmetrical. That means your neighbor is staring at the exact same choices and payoffs that you are. And if they're thinking rationally, they're going to do the same analysis and come to the exact same conclusion. Steal is their dominant strategy too. And this is where it gets really, really interesting. So we've got two rational players. We've proven that both of them have a clear dominant strategy, and it's to steal. What do you think is the inevitable outcome when they both play their best move? Well, they both choose steal. Your dominant strategy crosses with their dominant strategy right here in this bottom right box. The final outcome is steal, steal, and you both walk away with just 2 points. This predictable result is what we call a Nash equilibrium. But
there's a big problem. This exact situation, where perfectly rational, self-interested choices lead to this kind of outcome, has a very famous name: the prisoner's dilemma. And it's called a dilemma because it uncovers this totally mind-bending paradox at the core of strategic thinking. Here it is, laid out plain as day. The completely logical, rational choice for both of you leads to an outcome where you each get 2 points. But just look, if you had both somehow managed to cooperate and choose forbear, you could have each walked away with 7 points. It's wild. Individual rationality leads to a collectively worse result for everybody involved. And this isn't just some abstract little game. It connects to really deep philosophical ideas. The philosopher Thomas Hobbes talked about a state of nature as a war of all against all, where without trust, life is basically miserable for everyone. The prisoner's dilemma is pretty much the mathematical proof of that exact idea. Which leaves us with one last, pretty unsettling thought. If acting perfectly rationally in our own self-interest can lock us into a worse outcome, does that mean that sometimes our own logic is the biggest thing standing in the way of a better result? Something to chew on.